So today we're going to be making an amortization table for an example with increasing contributions in arithmetic progression. So just a reminder, what do we mean by arithmetic progression? We mean that the payment is going to be the same dollar amount more than the last payment every single time. So let's take a look at this example. It says that a company has taken out a loan of $750,000 to be paid off in 4 years. The financial manager of the company decides to establish an amortization fund, increasing the payments by $40,000 each year. If the money is invested earning a 10% interest per annum compounded annually, determine the value of the first payment and prepare the table for the amortization fund. Okay, so first, let's just recap. Well, what do we know? We know that the future value must be $750,000 because that's how much money we're going to need to have in 4 years from now when this debt is to be paid off. In 4 years from now, we need to have $750,000 in 4 years from now's money, essentially. So $750,000. Now, in order to tackle this, we're going to be making annual payments, and the payments are going to increase by $40,000 each year. So that tells us that G, the gradient amount, is $40,000, since that's how much extra we're going to be paying every year compared to the previous year. N is going to give us the number of payments. In this case, it's 4 because it's one payment every 4 years. And then the interest rate per period is going to be I. In this case, it says that there's a 10% interest per annum, and we are making payments every year. So therefore, 10% is fine. We don't need to adjust that in this case. The one thing that we don't have that would be really nice to have for making our amortization table is, well, what's our first payment? Or really any of the payments would work, because if we knew any one of the payments, we could just add 40,000 or subtract 40,000 however many times we needed to in order to find all the other payments. So what I'm going to do is I'm going to be using the formula for the future value of an arithmetic gradient in order to find the first payment. So just a reminder, how do we do that? Well, that equation states that the future value is equal to the first payment times 1 plus I to the power of n minus 1 all over I plus g over I times 1 plus I to the power of n minus 1 over I minus n. So now I'm going to plug in the values we have, because we have all of these values given to us in the question, except for A, which is the first payment, and that's what we're trying to figure out. So therefore, the future value of $750,000 is equal to A times 1.1 to the power of 4 minus 1 all over 0.1 plus 40,000 over 0.1 times 1.1 to the power of n minus 1 over 0.1 minus n, which is 4. Okay, so now let's figure out what this is. So let's first start by figuring out what the coefficient of A is, so what that number is there. So for that, I'm going to type in 1.1 to the power of 4, hit equals, minus 1, hit equals again, divided by 0.1, hit equals again, and I get 4.641. 4.641 times A, and then I'm just going to repeat the 750,000 on our left, and then I need to find what this number is. So to find what this number is, I'm actually going to start by finding what's in the brackets, and then just multiplying by 40,000, dividing by 0.1 is probably the simplest way to do that without making an error. Oh, and I just noticed that this says n. This should say 4 because this next step is where we plug in the n value. So there shouldn't be any other variables left other than A, since that's what we're trying to figure out here, that first payment. Okay, so 1.1 to the power 4 equals minus 1 equals, divide by 0.1 equals, we should get the same thing that we got before. Then minus 4 equals times 40,000 equals, divided by 0.1 equals. That's $256,400. So now we just have a regular linear equation. So now what I'm going to do is subtract $256,400 from both sides to get that $493,600 is equal to 4.641 times A. Therefore, A is going to be equal to 493,600 divided by 4.641, which if we type that in a calculator, we get $106,356.39 approximately. It's actually 38.87 and some other stuff probably, but we're just going to cut it there and round it to the nearest two decimal places for dollars and cents. Okay, so there we go. Now we figured out the first payment. So now let's talk about how we can actually make this amortization table, because that's probably really why everyone's here, is to know how to make the table. So let's start with the period in years. And then next we're going to have the deposit amount, then the interest, and then the fund balance. So those are our categories. There we go. Let's draw a nice line like that. Excellent. And maybe some other lines like that too. Okay, so years, I'm going to write 1, 2, 3, 4 because there's 4 years. Year 1, year 2, year 3, and year 4. Draw a nice line at the bottom too, I suppose. Okay, and then the deposit, interest, and fund balance. So here's the thing. The very first deposit we make is this number we found here. It's going to be $106,356.39. The interest we made that year is nothing because we didn't have any fund balance from the previous year. So the only fund balance we have as soon as we deposit that money is just the money we deposited. So we have that $106,356.39. Okay, next we need to find out, okay, well, how much interest are we going to make on that money? Well, in year 2, that means 1 year has passed. And so that means that we are going to be making, well, what percent was it? It's 10%. Okay, so 10% of this. So 106,356.39 times 10% is going to give us $10,635.64 of interest, which is pretty great. We're also going to make another deposit, and keep in mind, because it's arithmetic progression, where every year the deposit amount goes up by 40,000. That means it's going to be $146,356.39 as our deposit this time. So now for our new fund balance, we have 3 things. We still have the money from the previous fund balance, which was the 106,356.39. Now we also have the interest, which is the $10,635.64, plus we have the deposit that we just made of $146,356.39. So now I'm going to add up all 3 of those numbers, the deposit we just made, plus the interest that we made on the previous deposit, plus the previous fund balance, all together. And if I add up these 3 numbers, 1, 2, 3, I get $263,348.42 is our new fund balance. Okay, now how much interest do we make on this new balance? Well, we make 10% a year, so the next year, therefore, we get 10% of the fund balance, which is $26,334.84. Now we also make a new deposit as well, which is going to be $40,000 more than the previous deposit, so that's going to be $186,356.39. And now if we add up these 3 numbers, which are the fund balance last year, plus the interest we made on that this year, plus the deposit that we just made this year, we get, well, let's see, 263, 348, and 42 cents, plus the interest, plus 186, 356.39. That gives us $476,039.65 as our new balance. Okay, and how much interest are we going to make on that? Well, 10%. So that's going to be $47,603.97. Great. All right, and then now we're going to also make a new deposit that's $40,000 more. So that's going to be $226,356.39 plus the interest that we just made, plus the previous balance. And here we're expecting to get a number that is very, very, very close to that, the number we had in the beginning, that $750,000 number. If we get something that's way off from that, then that means we have likely made a mistake somewhere. if we get something that's a few cents off, especially when we're talking about a $750,000 thing here, if we get something that's under $1 off, it's probably just due to some rounding errors somewhere. The fact that each time we're rounding to just 2 decimal places because we're dealing with money here in this case, and so that would explain that. So if it's ever so slightly off, don't worry about that. But if it is more than, a few cents off, then that is a problem. Okay, so yeah, so let's see what I'm getting. I am getting $750,000 and is 0.0052, right? And so that means that's actually going to round up to 1 extra cent. But again, that's completely fine. If we get 1 or 2 or even 3 or 4 or 5 cents, that's really nothing in comparison to, when we're talking about a $500,000 balance. It means we have done everything correctly. There's just a small discrepancy somewhere because of the way we round in, when we write these. So that's completely fine. Okay, so now we're going to add up the total deposits and the total in interest here. So for the total deposits, that's going to be 106, 356 and 39 cents plus 146, 356 and 39 cents plus 186, 356 and 39 cents plus 226, 356 and 39 cents. So in total, we paid $665,425.56. And the total interest we would have paid is going to be, we can add up those 3 numbers here, or we can actually just do this number minus this number to get the interest. Also should work as well. Either way is fine though. So $10,635.64 plus $26,334.84 plus $47,603.97. So that's a total of $84,574.45 overall. So there we go. As always, if you have any questions, please leave those down in the comment section, and we'll see you for the next one, which is going to be about a similar example, but with geometric progression instead of arithmetic.